In this video, we're asked to graph the circle x squared plus 2x plus y squared minus 4y minus 4 equals 0 and state the maximal domain and range for the relation. The first thing you'll notice is that it is not in a form where we can immediately see the center and radius of the circle. So what we need to do is we need to complete the square with respect to x and y. So if I color code this, all the x terms are in blue and all the y terms are in green. So if we complete the square for x, we find that we have x squared plus 2x. We're going to take the b term, which is 2. We're going to halve that, which is equal to 1, and then we square that number, which is still 1. And we add that on, and then immediately take it away again. So that helps to maintain the equality. So we haven't changed the equation, we're just adjusting the way it looks. Next up we have the y, so we have plus y squared minus 4y. And now again we look at the b term in front of the y raised to the power of 1. So in this case it's minus 4. We halve that to get minus 2. We square that number to get positive 4. So we have positive 4, and then we subtract 4 away to maintain the equality, and then in the equation we've still got another minus 4, which was originally up here, equals 0. So the first three terms here become a perfect square. So we have x, and then the half b term sits here, so x plus 1 all squared. And then the same thing happens for y, so the first three terms here become a perfect square, so we have y, and then we have the half b term, which was minus 2 all squared. And then we've got those are added together, and now we've still got minus 1, minus 4, and minus 4 left over, and all of that is equal to 0. So these three terms here add up to be minus 9. So what we can do is we can rewrite our equation as x plus 1 all squared plus y minus 2 all squared. And then if we plus 9 to both sides, we get that that is equal to 9. And this equation here, we can work out the center radius of the circle. So here's the equation we just found, and now that it's in this form we can work out the transformations that have occurred. So the first thing we can notice is that the circle has a radius of 3 units, and that is because we take the square root of this number here. So the square root of 9 is 3. The next thing we can notice is that it's translated 1 unit in the negative x direction. That's because of the x plus 1 here. So if we have x plus 1 equals 0, we have x is equal to negative 1. And then we can work out that it's being translated 2 units in the positive y direction, and that's because of this. So if we have y minus 2 equals 0, we get y equals positive 2. And because of those last two bits of information, we can work out that the center of the circle is at negative 1, 2. So what we need to do now is find any axial intercepts for the graph. So if we start off by finding the x-intercepts, which occur when y is equal to 0, we find that x plus 1 all squared plus 0 minus 2 all squared equals 9. And now minus 2 squared gives positive 4. So we can write this as x plus 1 all squared plus 4 equals 9. Subtracting 4 from both sides, we find that x plus 1 all squared equals 5. Now if we take the square root of both sides, we find that x plus 1 equals plus or minus the square root of 5. And finally, if we subtract 1 from both sides, we have x is equal to minus 1 plus or minus the square root of 5. So that means we have our two x-intercepts. We have it at -1 minus root 5, comma 0. And we have our other one at -1 plus root 5, comma 0. Now that we've found our x-intercepts, we need to find our y-intercepts, which occur when x is equal to 0. So if we do that, we get 0 plus 1 all squared plus y take 2 all squared is equal to 9. Now, 1 squared is just 1, so this can be written as 1 plus y minus 2 all squared is equal to 9. Subtracting 1 from both sides of the equation, we find that y minus 2 all squared is equal to 8. Taking the square root of both sides, we find that y minus 2 is equal to plus or minus the square root of 8. And now if we just do a little side calculation, the square root of 8 is equal to the square root of 4 times the square root of 2. And the square root of 4 is of course 2, so we have the square root of 8 is equal to 2 root 2. So the last thing to do is add 2 to both sides. And once we do that, we find that y is equal to 2 plus or minus 2 root 2. So this gives us the two y-intercepts. The first one is 0, 2 minus 2 root 2. And the second one is 0, 2 plus 2 root 2. So on this slide, we found the center of the circle, which is at -1, 2, 2 x-intercepts, and 2 y-intercepts. So on this slide, all the x and y-intercepts have been plotted, the circle's gone through them all, and the center is shown. So the next thing we can do is work out the extreme points on the circle. So if we take the x-coordinate of the center, which is -1, and we add on the radius, which is 3, we get to this point here, which is 2, 2. And then if we go from the x value at the center, which is -1, and subtract the radius, which is 3, we go to this point, which is -4, 2. And now if we repeat this by taking the y value, which is 2, and adding on the radius, which is 3, we find that this point here is -1, 5. And finally, if we take the y value, which is 2, and subtract the radius, which is 3, we get to this point here, which is -1, -1. So now that we've got all the extreme points on the circle, we can find the domain and range of this relation. So the domain is all the x values that are allowed in the circle's equation. So if we scan across left to right, we see that the smallest possible value is -4, which is included, and we go all the way through till +2, which is also included. Then if we repeat the same process for the y, we find that y is an element of the smallest y value, which is included, so we use a square bracket, -1, all the way through until 5, which is also included, so we also use a square bracket for that. So on this slide, all the key features of the circle have been plotted, and over on the right hand side, we've restated our maximal domain and range for this circle.